This is spiral review for spiral 5. First thing we have to do is sketch the graph of the function that's given. I know that square root functions generally look like this. The minus 2 is going to move that 2 units to the right. The minus 3 is going to move it 3 units down. And the 2 in front is going to make it steeper. The 2 is going to make that twice as steep, which means our final graph is going to look something more like this, with an endpoint at 2, -3. Our next problem is based on writing the equation for this function based on this graph. The general function there is an absolute value of x. It looks to me like it's been moved down 1, so that would make that absolute value of x minus 1, and that here we have a slope of 2 over 1. That would make that y equals 2, absolute value of x minus 1. Our third question asks about the domain and range of a couple different functions. First of all, we've got a square root function, and the rule for every single square root function is the same. Whatever's on the inside, so the stuff inside the radicand has to be greater than or equal to 0. That gives us an inequality. Negative x plus 7 is greater than or equal to 0. Solving that, I end up with, okay, let's add x to both sides to get rid of that negative. 7 is greater than or equal to x. For all fractions, the domain is the same rule also. The denominator cannot equal 0. So given that rule, we set 2x squared plus 5x plus 3, and we make that not equal to 0. Okay, let's factor that. To factor that, I'm going to end up with a 2x and an x. We end up with a plus 3 and a plus 1. That cannot equal 0. We're going to end up with 2x cannot equal 3, so x cannot equal 3 over 2, and an x cannot equal negative 1. These two statements are shorthand for our domain and will give us enough information. Our next one asks us to find the inverse of a function. We know the first step is to set it equal to y, so y equals cube root 4x minus 3. Next step is to switch x and y. X equals cube root 4x minus 3. And then, there should be a y over there, sorry guys. And then try to get that y by itself to get rid of a cube root. We raise both sides to the third power. I get x cubed equals 4y minus 3. Add 3 to both sides. X cubed plus 3 equals 4y. Divide both sides by 4. My answer is x cubed plus 3 over 4 is k inverse of x. Our next problem asks us to do some operations on functions. The first one asks us to do f plus m minus g of x. Please remember that the x at the end tells us what variable we're using. It does not tell us to multiply by x. We quite literally take f of x plus m of x minus g of x. Okay, f of x is x squared minus 13x plus 27. G of x is I'm sorry, I'm doing m of x next, so it's plus 2x squared plus 5, and then g of x is 3 minus 11x, so it's minus 3 minus 11x. If I combine stuff, I get 3x squared. I've got a minus 13 minus negative 11 is going to be minus 2x. And I've got 27 plus 5 is 33. I'm sorry, 32. Minus 3 is 29. The next one asks us to do 3 times g over m of x and plug in negative 1 for x. Please remember this means plug in negative 1 for x and not times negative 1. So if I set that up, that's 3. G of x is 3 minus 11x. M of x is 2x squared plus 5. Okay, now I'm going to plug in negative 1. That becomes 3 times 3 minus 11 times negative 1 divided by 2 times negative 1 squared plus 5. Okay, so we've got 3 times negative 11 times negative 1 is positive 11. Negative 1 squared is 1. 2 times 1 is 2. So I get 3 14 over 7, which is 2. 3 times 2 is 6. Our next one asks us to take a look at f of g of x. That means plug g of x in to f of x. Okay? I'm going to clear a little bit of room first, if it'll let me, which it won't. So we've got x squared minus 13x plus 27. And in there I'm going to insert g of x. So instead of x squared, I'm going to write 3 minus 11x squared minus 13 times 3 minus 11x plus 27. Last one on this page, g of m of 2. I take g of x, 2x squared plus 5, except that's m of x. So I guess that's what I'm going to plug in to g of x. So g of m of x is going to be 3 minus 11. Instead of m of x, I'm going to write 2x squared plus 5. And that's my answer. We're going to continue with factoring. First we have 7x cubed minus 42x to the fourth. In here I notice I have 7 times x times x times x. 42 is 6 times 7, and I've got 4 x's there. 1, 2, 3, 4. I look for stuff they have in common. They both have a 7, and they both have 3 x's. Okay, so that means I'm going to have 7x cubed on the outside. If I take 7x cubed out of 7x cubed, I'm left with 1. And the second part of my inside is going to be minus 6x. Moving down to factoring some quadratics. This first one is already set up for grouping for us. What that means is I'm going to look at my first 2 terms and look for something in common. I'm going to look at my second 2 terms and look for something in common. In my first two terms, it looks like I've got 15x squared and a minus 20x. Well, I know 15 and 20 have a 5 in common, and x squared and x have an x in common. What's left over is going to be a 3, and that's an x, and a minus 4. Okay, my second two terms, I've got 21x and negative 28. That means I've got a 7 in common. If I pull a 7 out of 21x, I get 3x. Pull a 7 out of negative 28, I get minus 4. Hey, that works out kind of nicely, because now I've got a 3x minus 4 in both parts. Okay, I'm going to put a 3x minus 4 out in front, put that in parentheses, and then I've got a 5x and a plus 7. Next problem, 2x squared plus 17x plus 26. This one is not already set up for us, so one of the things that I could do is try to set it up myself for grouping. 2x squared plus something x plus something x plus 26. My quick rule of thumb is I'm trying to find numbers that multiply to these two things multiplied together. So that's 52, and add up to the middle piece, so add up to 17. Okay, numbers that multiply to 52. I know I've got 52 times 1. That doesn't add up to 17. I know I've got 26 times 2. That also doesn't add up to 17. I've got 13 times 4. That does add up to 17. Okay, let's see. 13 and 4. If I plug these things in, so stuff that's common between a 2 and 13, okay, I think that's just going to be an x, right? So I get x times 2x plus 13. The next I've got 4x and 26. They look like they have a 2 in common also. So if I do a 2, I've got 2x left over and a 13 left over. Now I've got 2x plus 13 in both places. And I've got an x and a plus 2 left over. That worked out kind of nicely. Okay, now we're moving on to solving equations. In the last couple we did some factoring, now we're going to solve. First thing I want you to do is to get everything to one side. So I can rewrite this as 3x squared plus 25x plus 8 equals 0. Now I'm going to factor. I take my 3 and my 8, looking for things that multiply to 24 and add up to 25. That sounds a lot like I'm going to have a plus 1x and a plus 24x. Okay? If I factor stuff out of the front, I get an x and a 3x plus 1. If I factor stuff out of the next part, they both have an 8 in common. I'm going to have an 8 and a 3x plus 1. I'm going to have a 3x plus 1 and an x plus 8 equals 0. That means that 3x plus 1 equals 0, which means that x could equal negative 1 over 3. And from my x plus 8, I get x equals negative 8. Those are my two solutions. Moving down, I've got 100x squared equals negative 700x minus 1200. The first thing I notice, all three of these numbers are really big. In fact, all three of these numbers are multiples of 100. What happens if I start out by dividing by 100 on each of them? I get x squared equals negative 7x minus 12. That seems a lot more manageable. Let's bring it all to one side. X squared plus 7x plus 12 equals 0. And I'm going to look for two numbers that multiply to get 12 and add up to get 7. It's going to be x plus 3, x plus 4 equals 0, x equals negative 3, and x equals negative 4. That's all that's going to be graded on this week's spiral. However, if you'd like to get a little bit of a head start on stuff we're going to see next week, take a look at these next few examples. We're moving on to complex numbers. Complex numbers are things that involve the square root of negative 1, which we also know as I. In our first problem, we have 2x squared plus 18 equals 0. If I move the 18 over and then divide by 2, I end up with x squared is equal to negative 9. Normally, I would take the square root of both sides, giving me plus or minus x equals the square root of negative 9. Here's the funny thing. If I have the square root of negative 9, there's no number in the real number system that works for that. So I've got to think about this as 3 or negative 3, and both of these are going to be times the square root of negative 1 or times I. Okay? My next one, 7x squared plus 35 equals 63. All three of those look like they can be divided by a 7 to me. So I got x squared plus 5 equals 63 divided by 7 gives me 9. Minus 4 to both sides, x squared equals 4. Square root both sides, and I get x equals plus or minus 2. It's kind of nice when that works out. We don't have to deal with any imaginary numbers for that one. The next things ask you to simplify each complex expression. Generally, we treat the imaginary number I as we would a variable. So I'm going to multiply these out with double distribution. 2 times 3 is 6. 2 times 2i is 4i. Negative 7i times 3 is minus 21i. And negative 7i plus 2i is minus 14i squared. The cool thing is, if I equals the square root of negative 1, I squared equals the square root of negative 1 times the square root of negative 1, which is just negative 1. So when we do these, we're going to have things that cancel out rather nicely. And that's negative 1. Negative 14 times negative 1 is plus 14. 4i minus 2i is 2i, and then I've got my 6. 6 plus 14 is 20, plus 2i. Okay, we've got 4 minus 7i times 1 plus 5i. Let's start that out. 4 times 1 is 4. 4 times 5i is 20i. Negative 7 times 1 is minus 7i. And negative 7i times 5i is plus 35. Sorry, that's a negative 35. I squared. Remember that I squared is negative 1. So negative 35 times negative 1 is plus 35. 20 minus 7, we've got 13i, which turns into 39 plus 13i. Again, that part's not going to be graded on tomorrow's spiral, but if you'd like to see what you can do, go for it. From here, we're going to break up our fractions somewhat and set up as the sum of two limits. We're going to go with the limit as h approaches 0, negative sine x times 1 minus cosine h all over h plus the limit as h approaches 0 of cosine x sine h over h. There are a couple cool things that happen here. The first is I have one of my special trig limits. The limit as h approaches 0 of 1 minus cosine h over h. That's going to turn into a big 0. And when multiplied times the limit as h approaches 0, negative sine x, that whole first term is going to go away. The second cool thing is I have my limit as h approaches 0 of sine h over h. That's my other special trig limit. That one's going to equal 1. So here we've got 1 for the sine h over h. I've got cosine x times 1. The derivative of sine of x is cosine of x.